In this video, we're going to look at conditional relative frequencies. So these are relative frequencies, those percentages that depend on conditions. So let's look at an example. A coach asks her athletes if they enjoy running. 55% of the team do not like to run. So I'm going to start by writing a 0.55 down here, and I can tell that the other percentage must be 45% or 0.45, just subtracting that from 100%. So of these that do not enjoy running, 70% enjoy cycling. And the way I'll calculate that number is 0.7 times 0.55. So I'm multiplying 70% times 55%. And for that, that gives me 0.385. That's 38.5%. And the other parts, so these 70% enjoy cycling, while 80% of those who enjoy running also enjoy cycling. So here I'm looking at the other side, those that enjoy running and enjoy cycling. That means I'm going to do 0.8 times 0.45. So it's 80% times 45%. And let me multiply that real quick. So I've got 0.8 times 0.45. And here I get 0.36. Or 36%. So the questions ask me, what is the total percentage of athletes who do not enjoy cycling? For that, I'm going to have to do a little more work here. So who does not enjoy cycling is going to be 0.2 times 0.45. So I get that 0.2. This is 20%. That's the rest of this 80%. So I just subtract that from 100. And the 45% was from here. So I multiplied those together. Let's do that real quick. 0.2 times 0.45. And here I get 0.09. All right, so 9%. And I'll do the same thing down here. Let's keep these separated. So down here, I'll do the same thing. This was 0.7, so this must be 0.3. I just get that from doing 100% minus 70% equals that 30%. And I'll times this by 55%. All right, so I'm doing 0.3 times 0.55, and I get 0.165. Or I could say 16.5%. So what is the total percentage of athletes who do not enjoy cycling? It's really just going to be adding these two percentages together, 0.09 and 0.165. So if I add those together, I get, let me change my color. So here I get 0.255. When I add these together, or as a percent, that would be 25.5%. All right, so a little confusing with that one. It's definitely tricky to make sure that you are reading it correctly, especially the way that they have things worded. It's very easy to put a number in the wrong place. And let's look at our next example here. A study shows that 72% of the population has high blood pressure. And I can start by filling that in down here, has high blood pressure. The total for that would be 72%. The study also shows that 32% of those who do not have high blood pressure exercise at least 90 minutes per week. So this one's a little tricky. Here I'll be looking at those who do not have high blood pressure. So I'll be looking at this cell here, this square, does not have high blood pressure, and they exercise at least 90 minutes per week. And the way I'm going to do that is 32% times this total over here. All right. So we have to work a little backwards here. I know that the full total should be 100%. And to get this one, if I just do 100 minus 72, I'm going to get 28. %. So that means what I'm doing to figure out this cell is I'm doing 0.32 times 0.28. And for that, I get 0.09, which is 9%. All right, and then let's do this other part. So while 86% of those with high blood pressure exercise at least 90 minutes per week. So I'll be looking at this square here, this rectangle has high blood pressure. They exercise at least 90 minutes per week. This is going to be 0.86, and it's 86% of the total. So 86% of 72.72, and I multiply those together, and I get 0.62. Let me write that as a percent, 62%. All right, now for the rest of this, I can really just fill this in by subtracting these from 100. So let me switch my color. So if I do 62 plus 9, that gives me 71%. I could subtract these, 100 minus 71, that gives me 29%. Up here, if I do 28 minus 9, that's going to give me 19%. And this last one, 72 minus 62, that gives me 10%. All right, so be careful with these. Really, that tricky part is reading this correctly. It's very easy to kind of switch things around, and you'll end up doing the problem sort of backwards, and you'll get a different answer. So just be very careful with how you read this. And our next example, the following segmented bar graph shows whether adults and children enjoy riding roller coasters at least once a year. And they're asking us how many more times likely are children to enjoy riding roller coasters at least once a year than are adults. So let's look at our segmented bar graph. Here's the children that do enjoy. They do enjoy riding roller coasters, so that's the blue. And that looks like about 70%. And for the adults coming over to here, it looks like that is about 25%. And to figure out how many more times is this number than this number, I'm really just dividing these. So on my calculator, I'm dividing 0.7 divided by 0.25. And that gives me 2.8. So you can think of it as if I multiplied 25% times 2.8 times, I would get this number 70%. And that's our answer. And our next example, a teacher collected data from students to track whether they had completed the test review before their most recent test and whether they passed the test. And the table below shows their relative frequencies. So here they are asking us what percentage of students who completed the test review also passed the test. So I'll be looking here at these cells. I'll be looking at completed the test review and who passed the test out of the total. And all I'm really doing is I'm just dividing these numbers. I'll be doing 58% out of 66%. And the way I type that in my calculator is just 0.58 divided by, sorry about that, divided by 0.66. I think I made it worse. I hope you could tell that's a 66%. And when I divide those, I get 0.86 8788. And as a percentage, that is just 87.88. Okay, and our last example here, this is definitely a tricky one. Let's read through it first. A musician kept track of the concert arenas on this year's tour and found that 70% of the arenas were sold out. Of those that were not sold out, 20% had been on the previous tour schedule from last year, while 90% of those that were sold out were on the previous tour schedule. So you can tell this is already getting a little complicated, and they're asking us which of the following represents the joint relative frequency of arenas that were sold out and were not on the previous tour schedule. All right, so what I'm going to do for this is I'm going to make a little tree diagram just to simplify all this complicated information. And we're going to look at arenas that were sold out, and then also the ones that were not sold out. All right, and let me get us some, there we go, get us some rectangles in here. So these were sold out, these were not sold out, and then we'll look and see who was on, this will be for the previous schedule, not on the previous schedule, and the same for these two. So previous schedule and not. So of those that were not sold out, let me back up. So he found, after tracking the concert arenas, 70% of the arenas were sold out. So that's going to go over here. 70% were sold out. And subtracting from 100, that means that 30% were not sold out. Of those that were not sold out, so looking at this one, 20% had been on the previous schedule from last year. So I'm just going to write 20% over here. And then again, subtracting from 100, that means that 80% must have not been on the previous schedule. And the last part of the question, while 90% of those that were sold out were on the previous tour schedule. So that's going to go here, 0.90, 90%. Subtract that from 100 to get this one, and I get 10%. So my last step here is they're asking us for the joint relative frequency of those that were sold out and not on the previous tour schedule. So that means I'm looking at this number that was sold out and this number that was not on the previous tour schedule. So to combine these, all I'm really doing is just multiplying these together. I'm going to do 0.7 times 0.1, or you could say 70% times 10%. And I'll do that on my calculator, 0.7 times 0.1, and I get 0.07. All right, now as a percentage, that is just 7%. So this one, again, the math is pretty simple here, but the word problem, it's pretty tricky to make sure that you're putting things in the right place, and definitely have to read that very carefully to make sure that we're doing the right thing. All right, I hope that helps you out.